Now that we've compared and contrasted the Java platform threads and Java virtual threads, it's time to take a look at some key methods in the Java thread class. We're not going to try to cover all the methods in the Java thread class, just some of the ones that are most commonly used. Certain methods in the Java thread class are used in many concurrent Java programs. In fact, some methods, such as start and run, are used in practically all Java concurrent programs. The start method allocates thread resources, such as the runtime stack if it's a platform thread, and then initiates thread execution by calling the run hook method that we'll talk about momentarily. The start method can only be called once per thread object. Moreover, this method can be called to start both platform and virtual thread objects. Start virtual thread allocates virtual thread resources and initiates thread execution by calling the run hook method. As with the start method we just discussed, start virtual thread can only be called once. Moreover, this is a static factor method that returns a started virtual thread object. The run method supplies user code to a thread to execute. It's a hook method that can run any type of code. A hook method is a method that gets called back by a framework to provide some application or service-specific functionality. Set priority and get priority are mutator and accessor methods, respectively, that set and get the priority of a thread. Higher values of the priority passed to set priority will result in higher priority threads. In other words, the scheduler gives them preference when deciding amongst which threads to run next. The set daemon method marks a thread as a so-called daemon thread. A daemon thread is a background thread that doesn't prevent the Java execution environment, such as the Java virtual machine, from exiting when all user thread objects have finished running. Daemon threads are often provided by libraries or frameworks that perform background services invisibly on behalf of other user applications. The sleep method is used to put the calling thread to sleep for a given amount of time, specified here in milliseconds. There are other versions of sleep that take time unit parameters that have higher resolution than milliseconds. Sleep is primarily useful for stubbing out code in examples or sometimes in tests, and not much else. So make sure you use it very sparingly, if at all. Current thread is a static method that obtains the object that's associated with the thread that invokes current thread. It's most frequently used for debugging and logging, and can sometimes be used in various data structures like a hash map to keep track of which threads are executing in a program. The interrupt method posts an interrupt request to the designated thread object, indicating that its interrupt status is enabled. Interrupt provides a mechanism for one thread to signal another thread to stop doing its current activity and handle the interrupt. Unlike operating system interrupts, which are asynchronous, preemptive, and often involuntary, a Java thread interrupt is synchronous, non-preemptive, and voluntary, which means that the thread that's interrupted must collaborate with the interrupting thread in order to handle the interrupt and not ignore it. The Java thread class provides several other methods that threads can use to determine whether they've been interrupted. For example, the static interrupted method shown here tests whether the current thread or the calling thread has been interrupted. This method clears the interrupted status the first time it's called, thereby marking this thread as no longer being interrupted. In contrast, there's another non-static method called isInterrupted, and this tests to see whether the designated thread has been interrupted or not. A thread can call the isInterrupted method on itself multiple times without affecting its interrupted status, thereby making it more flexible than the interrupted method, which clears that status the first time it's called. The join method can be used by one thread to wait for another thread to finish. In some respects, it's like the inverse of start. Start is used by one thread to bring another thread into existence, whereas join is used by one thread to wait for another thread to finish. Join therefore provides a simple form of barrier synchronization, where one thread can block its execution until another thread completes, and then continue on with what it was going to be doing next. The final two methods we're going to examine from the Java thread class are from recent, very modern versions of Java. The ofPlatform method is a factory method that returns a builder that creates a platform thread or a thread factory that creates platform threads. Likewise, the ofVirtualFactory method returns a builder that creates a virtual thread or a thread factory that creates virtual threads. We'll walk through case studies and assignments that will apply the of virtual and of platform factor methods throughout this course. So that's the end of our walkthrough of key methods that are commonly found in a Java thread. Naturally, we'll walk through more examples and case studies later that will illustrate how to apply these key methods in practice.